off the last two lessons, which are lesson 9, lesson 10. Lesson 9 is on page 569 of your workbook. So you want to be open to that page. And what we are doing in this lesson is, we're getting into these last two lessons of problem solving. So sometimes students, when they think of like problem solving for trig, that sometimes students don't like problem solving as much. But what I find, especially with trig, is that problem solving really puts this into perspective for students, because we've just been doing these, like, you know, the unit circle and crazy sine equations, crazy cosine equations, but how is that applied? And you're going to really see the application. And then I find that once students finish these two lessons, their understanding of trig is just solidified. So these two lessons are on sinusoidal functions. And there's two sinusoidal functions. The two are y is equal to the sine of x and y is equal to the cosine of x. So both of these are sinusoidal functions. Just to quickly illustrate, remember that a sine graph always starts at 0 and then rises, and this would be 1 period on a sine graph. So 1 period on a sine graph is going to be 2 pi or 360 degrees. But this is called sinusoidal because that just keeps repeating itself, right? So that shape would just keep repeating itself over a certain interval, and the interval is every 2 pi radians. The cosine graph is very, very similar to a sine graph, except remember that a cosine graph, it always starts at the peak. So it starts at 1 and goes to -1. So that's a cosine graph. And that period is over 2 pi radians, and it just keeps repeating itself. So it becomes a sinusoidal function, even though it's a cosine graph, because it will repeat itself. I hope you're able to see that I could turn this sine graph into this cos graph by doing a phase shift, right? If I take this pink, and this peak here would be at pi over 2, because we know that this is at pi. So if I go a phase shift, pi over 2 radians to the left, I've actually just become a cos graph. So these two are the same identical graph. They're just one's phase shift of the other, essentially. Or I could take this guy and go pi over 2 radians to the right, and it becomes a sine graph. Okay? So in the world, and in everyday life, there are certain things that, if graphs would follow this perfect sinusoidal curve. So it talks about here the time of sunrise as a function of the day of the year. If you plotted the sunrise every day, and they've done this, so we're going to do a question on it. If you plot the sunrise every day for a year, for 365 days, the sunrise follows a perfect sinusoidal curve. The height of a chair on a Ferris wheel, so that's going to be lesson 10. We're going to do that one. So even though it looks, you seem like you're going in a circle, it's actually going to be a perfect sinusoidal curve. We'll see. The depth of the ocean due to changing tides as a function of time, that's a sinusoidal curve. Okay? So we're going to just look at different real life examples. The first example that they give us, it says the depth of water in a harbor after midnight can be approximated by this function here. So students look at this and they sort of get nervous and they're like, okay, well, what is this? First thing I would do is I would rewrite this function, because we are used to seeing the a value first, then either sine or cosine, and the d value last. How many of you are able to look at this and tell me what the d value on this graph is? Viola, what's the d value? 12. Yeah. So what I'm going to do is I'm going to take this equation and I'm going to rewrite it, because I know that that's my d value. I'm going to put that at the end. So I'm going to rewrite this as 5 cosine 0. Oh, sorry, it should be, you can keep that, but I should have d of t is equal to, right? I'm missing the start of it. So depth of water according to time. So the depth of the water according to time is 5 cos 0.5 t plus 12. The reason why I want to see it this way is because now what I could do is I could say, oh, This is the midline of my graph. The middle of this graph is at 12. So D is equal to 12. Then I could see this A value, right? The amplitude of this graph is 5 units. So if the middle of the graph is 12, it's going to go up 5 and down 5. And I'll be able to figure out the max and the min. So just based on this, I want you to do a quick sketch over here. And just draw yourself 2 axes. Okay, and we're going to label this. Like, how would I label this if this was an exam question? So the first thing I'm going to do is you need to recognize that depth is your y-axis, because it's always y is equal to, right? So this is the y-axis. So instead of putting y here, I'm not going to put y there, and I'm going to put d there. That's the depth of the water. And it actually says right here, the depth of the water is in meters. So then in brackets, I'm going to put meters. So I always want the axes labeled, and then you need to tell me the units. So this is going to be in meters. This value here is always your x, right? It's your x goes inside the bracket, and this would be an x as well. So my x axis is time. So time is going to go on my x-axis. And it tells me right here the units. They want time to be in hours. So then in brackets, I'll put in hours. If you have a ruler, take out your ruler and a red pen, and I just want you to draw the midline. We're not going to count up to 12, doesn't matter. Just draw a line, and we're just going to designate that line as being 12. Like without even, you want to be able to draw a picture before you put it into your calculator. Like you want to be able to sort of visualize, because this is going to help us with our window, right? If you could figure out the window for these questions, you are set. Okay, so if this is 12, and then the height is 5, John, what's the maximum height of this graph going to be? It's going to be 17. So it is going to go up to 17. And Kelly, how low would it go?
8.
Nope. Is it 8?
Oh, 7.
7. Yeah, to 7. Okay, so that's going to be the max and the min of my graph. Now, this is a cos graph. Does cos start on the midline, or does cos start at the peak? It starts at the peak, right? If I go back up here, cos always starts at the peak. So this graph, it's going to look something, because it's a cos graph, it's going to look something like this. And because it's sinusoidal, I'm just going to draw more than one for now. Like I'm going to draw more than one period. So I draw 2 periods. Okay, based on this, let's see if we can answer some of these questions. So the first thing, determine the maximum and minimum depths of water in the harbor. So this takes into account the equation that we learned that we came up with in the last lesson. But remember the max depth, it's that D value, it's your midline. We know that the max is 17, right? How do we get though that maximum? It's the D value plus the absolute value of A. So how we get the max depth was the midline was 12 and the amplitude is 5. 12 plus 5 is 17. And I'm going to put meters because they want the depth, and that's in meters. The minimum depth was from last lesson, the D value minus the absolute value of A. So that would be 12 minus 5 is equal to 7 meters. The maximum and the minimum will tell you your range. I know the range of my graph now, right? But I knew the range before even figuring this out, right? Just by doing this little sketch, I knew my range. Determine the period of the function. In order to get period, you need your B value. So this is your A value, maybe we'll write it up top, but that guy is your A value. In front of your X is your B value, and this is my D value. So basically in this graph, there's no phase shift in this graph, no C value. So if my B value is 0.5, the formula for period is 2 pi divided by B, which is 2 pi divided by 0.5. 2 pi divided by 0.5 is 4 pi. So a few things. From this peak to this peak, it's 4 pi. Now, this is on your x-axis, which is in hours. So the question, the period, is actually 4 pi hours. So somebody might say, well, what's a 4 pi hour? Well, pi is 3.14, so let's figure out what 4 times 3.14 is. That's going to be 1 period. So on my calculator, if I go to 4 pi, 1 period is just over 12 hours, just over 12 and a half hours, okay? So 4 pi hours is 12.6 hours. So I'm going to write that the period is 12.6 hours. What that means is that this point right here is approximately 12.6 hours. And that means that this point is going to be like another 12.6 hours, so about 25 hours. Or you could even put like approximately 24 hours there. One day, you guys. The second peak is going to be about 24 hours later, slightly more. It's going to be 12.6 times 2. But that's 1 period on my graph, 12.6 hours. That's the second period. So I just, if they want me to show from 0 to 24 hours, that's why I put 2 days in here, because I'm going just past 24 hours now. Okay. Okay. Write a suitable window that could be used to display the graphical function. So normally we would start this and we'd say perfect diploma question. And even though this is a good diploma question, your answers could vary. So they've got like acceptable answers. So let's do our y-axis first. So our y-axis is the depth. According to this, I'm going to start at 0. I want to go a little bit past 17, right? Like I don't want to set my window to 17. That wouldn't be a very good window. So full marks would be saying 0 to 20, let's say, or 0 to 18, as long as your graph can be completely seen. I'm going to write 0 to 20. This scale as well, I'm going to go up by 1s. They would accept going up by 1s, going up by 2s, as long as the scale seems to make sense. For the x's, I'm going to look here. This really helps me with what they want me to set my scale to. They want to see at least a 24-hour window. So I'm going to go from 0 hours to 24. And then I'm going to set my window or my scale at 1. Again, if you put 2 there, you'd be getting full marks for that, right? But this is around what you should be setting. So what I want to do now with you, let's punch this into our calculator. We got to be in radian mode. We're going to enter what they gave us, and we're going to change our window. So I'm in radian mode. I'm going to go to y is equal to. You could punch it in. What I suggest for punching it in is punch it in exactly how they originally gave it to you, right? Just in case you mess something up by manipulating. So let's punch in 12 plus 5 cosine of 0.5x. And that guy has to be in bracket. I'm going to go right to window. So the x-axis is the time from 0 to 24 hours. And I'm going to go up by 1 hour. My y is the depth of the water from 0 meters to, I think I said 20 meters. I'm going to graph this. Okay, so there's our graph. Our midline's missing. If you wanted to put the midline in, you can put it in. Let's check a few things on here. Do you remember how to check on your calculator this y-intercept? So double check that. We say that it should be at 17, but let's double check. So second function, calculate a value when x is 0. The y-intercept is 17. So that's correct. The other thing I want you to double check is we think that this time, one period, is about 12.6 hours. So how you would check that on here, this is called a maximum. So let's check the maximum of this. You would have learned that in 20-9. So second function, calculate, let's look at the maximum. Go to that peak. The maximum is just the vertex at that peak, but it wants me to go left of it. So I'm going to go left and hit enter. It wants me to go right of the vertex. I'm going to hit enter, or right of the maximum and enter. So there it is. 12.56 hours. The depth is going to be at 17. So one period is 12.5 hours, basically. Okay, let's go and do D. What is the depth of the water to the nearest tenth of a meter at 2 a.m.? So what are they're asking? They're asking when time is 2 a.m. That is on my graph. When x is, this is like midnight. So midnight is 0. That's 1 a.m., 2 a.m. At 2 a.m., if you were to go up to your graph, what is that depth? So in order to calculate that, second function, calculate a value when x is 2. At 2 a.m., the depth of the water to the nearest 10 is 14.7 meters. So depth is equal to 14.7 meters at 2 a.m. There's an alternate way you can get this 14.7 answer. What you could do is, let's write our formula. So the depth, according to time, is 12 plus 5 cosine 0.5 t. If you typed on your calculator the depth at 2 a.m., so what we're going to type in, we're going to type in 12 plus 5 times the cosine of 0.5 times 2, time when x is 2. If you type this in, we are going to get that 14.7. So let's see if we get that. So if I quit this, 12 plus 5 cosine at 0.5 times 2. This is your other way to get it. So on your test on Thursday, you have a choice whether you want to graph it and use like your graph, or whether you want to just punch it in like this and get your answer. So, but the depth at 2 a.m. is 14.7 meters. Okay. E and F, these are the ones we got to think on, these two questions. What E says, a ship requires a minimum of 8.5 meters of water if they're in the harbor. So the ship's in the harbor and it needs at least 8.5 meters. If the water level goes below 8.5 meters, that ship's going to be grounded. So what it says is, what time to the nearest minute must the ship leave, like go back out to sea to prevent grounding? So what you're going to do for this question is this right here, 8.5 meters, you are going to type that into Y2 on your calculator. Okay. So on our calculators, in Y2, we're going to type in 8.5. So we'll go here, 8.5. And then we're going to look at the picture to see if we can make sense of this. Here is where the water level is above 8.5, and the ship is safe. This is the danger zone. This is where the water level is below 8.5. The ship cannot be in the harbor at this time, whatever time that is, or over here. Okay, it's got to leave. So at midnight, the ship could be in the harbor. At 1 a.m., the ship could be in the harbor. At 2 a.m., it's fine. At 3 a.m., it's fine. We got to figure out when does the ship need to leave the harbor or it's going to get grounded. We got to figure out what time this is, because it said what time after midnight. So if this is midnight, this is when the ship has to leave and go back out to sea, right? Because it's going to get grounded here. That on your calculator is an intersect. So second function, calculate, number 5. Go close to the intersect. So that guy there, hit enter 3 times. So enter, enter, enter. This, remember, is 1 a.m., 2 a.m., 3 a.m. It's at 4 hours, and we gotta figure out how many minutes this is. So I'll show you how we do that. So the time that the ship has to leave, our calculator said that it was 4.692386. Okay, they want to know how many hours, how many minutes is this. So this 4, that's at 4 a.m. or 4 hours after midnight. To figure out what this is in minutes, you're going to take that decimal and you're going to times it by 60. So how I'm going to do that on my calculator is I'm going to go to my calculator, I'm going to leave this screen. I want to get that X value, right? So let's type in X next to your alpha button, hit enter. That was the X value. So I know that's 4 hours after midnight, so I'm going to delete that 4. There's the decimal. How many minutes this is, you times it by 60 to get the number of minutes. So it's 41 minutes. Now, here's where we have to think. You guys, we got to think, is the answer going to be 4 hours and 41 minutes or 4 hours and 42 minutes? So let's write down both and let's see. So 4 hours and 41 minutes after midnight. Or rounding rules tells me I should go up to 4:42 a.m. But it's going to be one of these two answers. If I go back to the picture on the calculator, okay, at exactly that intersect, right, if we were to round, use rounding rules, he's in the danger zone. That's at 8.5 meters. So you guys, 4:42 is just below that red line. 4:41 a.m. is just above. Which one would you box in on a test? When does he have to leave the harbor? 4:41 is your answer. So rounding rules, students want to box this one in, but it doesn't make sense, right? He would have to leave just before, which would be that time there, okay? Then what F says, what is the next time to the nearest minute the ship can return to harbor? So going back to my calculator, here's where he has to leave. He's got to go out to sea here. It's too shallow here. They want to know when can he come back. He can come back here. So let's find what that is. Second function, calculate number 5. This intersect here, okay, it's at 7 a.m., right? 7 something. So let's figure out what time this is to the nearest minute. So let's write X is equal to that entire thing. So X is equal to, the intersect was at 7.873983. So that's going to be 7 a.m. or 7 hours after midnight. And I need to figure out that decimal, how many minutes that is. So I'm going to times that decimal by 60. Okay, so I'm going to get my X. I'm going to subtract the 7. And I'm going to times that guy by 60. Okay, so we got to figure out 7:52 or 7:53. So let's write both of those times down. 7:52 a.m. or 7:53 a.m. When can he come back to harbor? So going to the picture, just think, 7:52 is to the left, 7:53 is to the right. What would you box in? When can he come back to harbor? 7:53 is when he can come back. So your answer for that question. So it's like rounding rules tells us this, common sense tells us that. So that's the first question. There's only 2 questions for this lesson. Okay, class example number 2. In a certain town in Alberta, the time of sunrise for any day can be found using this formula. So this is a true thing. They've plotted the sunrise every single day, right? So tomorrow, you guys, is February 17th. You could Google on your phone, what's the sunrise going to be in Edmonton on February 17th? And they've got the exact time. The sun rises. It is a sinusoidal function. The sun rises on February 17th at the same time every February 17th. So this is the formula for a town in Alberta. They don't tell us what town. So a few things. Let's draw a Cartesian plane, and let's see if we could label our x and our y axes. Let's see if we could find our midline, and then we're going to just approximate the max and min. They're gross decimal numbers, so we'll just get a rough sketch. Okay, so hopefully you see that your y-axis is t for this example. And they want time. Time is in hours after midnight. So I'll show you what that means, hours after midnight, but time is basically in hours. So time goes on the y-axis here. What they want on my x-axis is that there, which is days. And you need to know how many days are in a year. Do you know what it is? It's 365. So in a year, there's 365 days. I mean, I guess more correctly, you could say, oh, isn't there 365.25 because of leap year every 4 years? But we'll just say 365 for this. Okay, what do you want my midline, Adrian, to be?
6.3.
6.3, yeah. So let's just do, I'm going to pick here, and I'm going to say that is 6.3, and I'm going to put a dot like that. Okay, so the midline is 6.3. If I said, what's the max of this graph? So let's just do it off to the side. The max of this graph is the d value plus the absolute value of a. So the max of this graph is going to be at 6.3 plus the absolute value of negative 1.79 is 1.79. So this graph is going to have a max at 6.3 plus 1.79, 8.09. That's going to be the max. And then the min of this graph is going to be 6.3 minus 1.79. $4.51. Okay, there is phase shifts happening, reflections happening. So I'm not going to be starting my graph at 0 here. What I'm going to do from here, let's punch it into our calculator, see what the picture actually looks like. Okay, I'm going to show you how to enter this on your calculator because it's a little bit scary. So on your calculator, we're going to stay in radian mode, but at least now I know my window. So let's go to y is equal to, let's clear this. And let's type in negative 1.79. So again, I just want to type it in exactly as I see this. The sign, the bracket opens, 2 pi. I'm going to open another bracket, d minus 78, or sorry, that's x minus 78. And then here, I'm going to divide by 365. I could have put that divide by 365 over here, like 2 pi divided by 365, but I find it's just easier to put it there. And then I've got to close another bracket, because I opened this first bracket, I must close that bracket. And then I got to put the d value in, which is plus 6.3. let's go right to our window now. And our window's going from 0 to 365 days. I've seen two scales that I like. Some students will do a scale of 1. They want each one to be 1 day. Some students will put a scale of 30 in here. Do you guys know what the 30 would represent? A month. Yeah, so it really doesn't matter, right? Doesn't matter. Okay, we're gonna go from 0. What would be a good Y max to put? Yeah, 9, 10, just as long as it's above 8, right? So let's go to 0 to 10. So 0 to 10, and I want my scale to go up by 1 hour. So let's hit graph. There's the picture. It doesn't quite look like a sine graph because you might be saying, oh, it's starting at this peak here. If I put in, I'll just quickly show you, I'll put in the midline at 6.3, just to show you that. You don't need to put this in. But we know that the midline is going to be at 6.3. So it's actually starting at a peak. It looks like a cos graph, but it was a sine graph that was just shifted. So that's my maximum, and that's my minimum. I've already got them listed. Let's just start at the peak, right, to draw this. So let's start here. Let's go like this. Looks slightly off, that's fine. Yeah. Okay. I'm going to explain what this time in hours after midnight means. This would be 4 hours after midnight. This would be 6 hours after midnight. So midnight is 0. This here is midnight. Midnight is 0. So this midline is at 6 a.m., just past 6 a.m., right? The latest the sun rises is at 8 a.m., right? That's the latest the sun rises at this town in Alberta. Is that going to be the summer or the winter? So what do you guys think? Do you think this down here, yeah, the latest the sun rises, somebody, Kelly said it, is this peak going to be the summer or the winter? Winter, right? The sun rises much later in the winter. This 4:51 in the morning, that's like sometimes in the summer, your sun's going to rise just before 5 a.m., right? That's going to be the summertime. This is going to be the longest day of your year, longest day of sunlight. This is going to be your shortest day of sunlight, is how that works. Okay, write a suitable window. So I think we did that. The X, we went from 0 to 365. You choose if you want to go up by 1s or by 30s, what you want your scale to be. The Y's, I went from 0 to 10, and then I said, let's go up by 1 hour. Remember that 0 is midnight. So that's like 4 a.m., 6 a.m., 8 a.m. Use the formula to determine to the nearest minute when the sun rose on the 127th day of the year. This is the first day of the year. I got to figure out where the 127th day of the year is. I'm going to get rid of this guy. I just don't want that in right now. I'm going to go back to my graph. The 127th day, second function, calculate a value when x is 127. Because remember, days of the year are on the x-axis. Here is the 127th day of the year. The sun rose just before 5 a.m. Let's figure out how many minutes that is, right? So I need to now get my y value. So your y is alpha 1, enter, get rid of that 4, and times that by 60. We could use rounding rules for this one because we're not worrying about like shit bottoming out. So on the 127th day of the year, which just happens to be May 7th, the sun rises at 4:58 a.m. So when x is equal to 127, t is equal to 4:58 a.m. So whatever city this is, I'm thinking this is going to be a city more south of Edmonton. The sun rises in May just before 5 a.m. Okay, determine on which days of the year the sun rises at 7 a.m. So 7 a.m. is right about, let's just say here. If that's 7 a.m., what are the 2 days of the year where the sun rises at 7? So that's going to be a Y2 question. Y2 is equal to 7 a.m. So then I go to my graph, and in Y2 I'm going to put 7 a.m. This day of the year the sun rises at 7, and this day. So it's going to be an intersect question. Second function, calculate an intersect. Enter, enter, enter. So this one we would say, and again, we could use our rounding rules for this. So on the 55th day of the year, so day 55, and day, what's the last one? Day 55 and day 284. The sun rises at exactly 7 a.m. The sun rises at 7 a.m. There are 4 questions that I want you to do, and I'm going to set up these 2 with you, so we'll talk about these 2. So if you just want to write down, circle questions 1, 4, 6, and 7. You want to watch the podcast for this as well, to make sure that you understand application questions. So it's lesson 15 on the podcast, and there's 4 parts to it, an A, B, C, and D. And then I'll show you how question 6 and question 7, they want to be in degree mode. So we'll sort of look at these 2 together. So let's look at question 6. So again, super messy equation, but we're just going to end up punching this into our calculator when we want to get the answer. Okay, so what it says, the graph below shows how the number of hours of daylight in a European city changes during the year. Okay, so what this graph is showing, the hours of daylight, they've got that on the y-axis, and I just want you to write that down, hours of daylight. And then we're going to think about this, like what would we change our window to? So this is like no hours of daylight. What's the maximum hours of daylight any city could have? What would it be? 24 hours, right? So they don't tell me anything up here, but if this is hours of daylight, you could have a city with no hours of daylight. I don't know if that exists. The max you can have is 24 hours of daylight. So I don't know where 24 would go, but when I change my window on my calculator, I'm going to go from 0 to 24 on the y-axis. Then what they're showing down here is April 21st, they want to be day 0. On the previous example, I think day 0 was January 1st, was what they wanted. But they're like, okay, let's go from April 21st to April 21st. So 365 days, that's telling me my scale, right? Or not my scale, but my window. It's going to go from 0 to 365. We could do a scale of 1 or a scale of 30. Here's where we got to figure out. What they say is, for number 6, midwinter is the day with the least hours of daylight. How many of you could look at your graph and find where midwinter is? Least hours of daylight. It'd be the minimum, yes. This point right here, that is midwinter. Because that is the least hours of daylight, right? Because if I got my y coordinate, that would be the number of hours of daylight. My x coordinate would tell me what day of the year it is, how many days in. So what it says for this question, midwinter is the day with the least hours of daylight. The number of hours of daylight to the nearest tenth of an hour will be. So basically what they want is, for this first one, they want that value there, right? What's that minimum? And they want the number of hours of daylight. So that means they want the y, whatever the y is. For number 7 is how many days after April 21st, so after day 0, how many days after does midwinter occur? They want to know what's that x value. So number 7, we're doing the exact same, like you're getting that minimum, and this will tell you what day after April 21st. So that minimum will give you the answer to 6 and the answer to 7. And when you punch this in your calculator, when I punched it in, it did work. I punched this in a bracket, right? So I punched that guy in a bracket. Then I had another bracket here, and I made sure I closed 2 brackets here. So I typed in 360x divided by 365, close bracket, close bracket. This needs to be in degree mode. It doesn't tell us if they've got the 360 there. Oh, actually it does. This is where it tells us. Yeah, right there. That's how we know that this guy's in degrees. Okay. So that should give you, you should be able to get the answers for those 2.